Hello all. In this video, I'm going to talk about probability density function and cumulative density function. We will understand what exactly they are and how we can interpret cumulative density function and probability density function. PDF. PDF is basically probability density function, right? Probability density function. So what actually is the PDF? Say that I have marks here. So 10 to 100, all right? And I have plotted something like this. So how we can interpret this? 0 to 10 marks. So how many people have got a 0 to 10 marks? And 10 to 20, how many people have got 10 to 20 marks in between this range? Similarly, 20 to 30, say that I have 25 students. Same thing like a 30 to 40, 50 to 60, and up to 90 to 100. So basically, it is saying that how many students have received or scored this type of marks. So basically, marks versus the frequency. So here you can interpret that, okay, 30 to 40 marks. So there are 30 students who scored marks between 30 and 40. So that is how we can interpret this, right? And so this is it looks like a normal distribution. So now what I'm going to do, I'm going to smoothen this curve, like say that something like this, right? So as soon as I draw such kind of a line, so this is basically my probability density function. As soon as I draw this line, as soon as I convert this into a probability density function, these frequencies will disappear. Now I will not have any frequencies, right? So now it is going to be our probability, right? So say 0 to 0.1, 0.2 up to 1.0, right? How I can interpret this? So we can interpret that, okay, 0 to 10, right? Let me take this color, 0 to 10. So what is the percentage? What is the distribution of this marks between 0 to 10? So I can say that it's a 0.12, something like that, right? The probability or the distribution of the marks between 0 to 10 is 12%. Distribution, if I consider 20, let's say that this is a 20, and if I draw imaginary line, maybe it is a 0.35. The distribution of the marks from 0 to 20 is about 35%, right? So the distribution of 40 marks, up to 40 marks, is having 40%. Similarly, if I say 100, right? So distribution of marks, right? So how many students have received 100% marks? So I can say that, okay, it's maybe 0.02, something like that, right? Similarly, I can say that what is the percentage of 90 marks, the distribution of the 90 marks, I can say that maybe 1.11. So if we add up all these percentage, it will lead to 100% or 1.0. Right? So that is how I can interpret this PDF, and it looks like a bell-shaped curve, right? Bell curve. So that is what the probability density function. I will be able to tell that, okay, getting a marks 60, the probability, or I would say the distribution of the marks up to 60 is basically 0.38 or something like that. So that I can plot these marks and try to find the distribution of the data. So that is basically probability density function, right? Now what I will do, I will use the same data and we'll see what is the CDF. CDF is a cumulative density function. So earlier we have seen this in the this diagram. So it was looking like something like this, right? It was looking something like this. So here what we are trying to do, I have the same marks here, all right? So now what is the, so it's basically, as the name says, CDF, cumulative density function. So it is keep on accumulating, right? That is why you see that how the curve goes, and it starts from here, and somewhere at some point it will start flattened, right? Because the data is going down here, right? If I say that, okay, the probability of the distribution of the data from 0 to 10 marks, it's basically 0.1 percentage. So it's not a percentage, 0.1. So it's a 10%, you can say. If you want to convert into a percentage, it is a 10%. So the same thing you can imagine in this distribution in the PDF, all right? So you can call it as a cumulative distribution function as well. So what is the percentage of a distribution of getting a marks from 0 to 20? It is something like this, right? So then it will keep on adding on top of the last point. So it is not going to come down. So it will keep on accumulating. That is why the name cumulative. So if I say that 90 marks, so the cumulative density function is basically, you can draw this imaginary line. So 90%, up to 90% from 0 to 90 marks, I will be able to say that, I can say that, okay, it is going to cover up to 95%, 0.95. So my marks from 0 to 90 are falling, or the distribution of the marks from 0 to 90 is having a 95%. And greater than 90 marks, I have only 0.5% from 90 to 100, right? From above this, yeah. Finally, it is going to end up at 100%, as you can see. So these are the imaginary lines. Greater than 90 marks, there is only 0.5%, right? So 0.5% means it's a point, in this case 0.95, and it is supposed to be 0.05. My bad, 0.05. Or you can say only 5%. It's just basically whatever I said. If it is in 0.8 or 0.7, if it is in a point, then if it is in a decimal, you just need to multiply with 100 and you will get a percentage. Very simple, right? Sometimes we keep talking in terms of a percentage and a p-value, probability. So if it is in a decimal, you have to multiply with 100, then you can talk in terms of a percentage. Otherwise, in terms of a probability or a p, right? So this is how I can interpret PDF and CDF. All right. So yeah, that's all in this video. And thank you for watching this video. See you in the next video. Keep learning.